All right, so we're going to look at finding the cube roots of 125i. So let's start by saying that z cubed is going to be 125i. So that means that z is going to be 0 plus 125i to the 1/3 power. So using de Moivre's theorem, I can say that this is going to be the cube root of 125, which is 5, cis 1/3. This is going to be a pi over 2 angle, so pi over 2 plus 2 pi k, where k is 0, 1, or 2, because I want 3 solutions. So my first one, obviously, is going to be 5 cis pi over 6. I can also think of taking my pi over 6 and adding 2 pi thirds multiples, if I just expanded that. So I'll get 5 cis, so pi over 6 plus 2 pi over 3, that's going to be 5 pi over 6. Or I would get 5 cis, now if I add another 2 pi over 3, that's going to give me 9 pi over 6. 5 pi over 6 plus 4 pi over 6. Yes, which is 3 pi over 2. So 5 cis of 3 pi over 2. Well, this one's just negative 5i. So if I think about taking negative 5i and cubing it, this one's an easy one to test. So I'm going to get negative 125 times I cubed. But of course, I cubed is just I squared times I squared is negative 1. So that's going to give me 125i. The reason I put this polar coordinates grid here is so that we can graph these solutions, because there's something interesting that happens graphically with the solution, with the roots of complex numbers. So if I graph my solutions, negative 5i is the easiest one to graph. So let's go 1, 2, 3, 4, 5. And now 5 cis 5 pi over 6. So that one's over here. 1, 2, 3, 4, 5. And then 5 cis pi over 6. 1, 2, 3, 4, 5. Did this one also go 5? Okay. Yeah, this one's a little bit too long. All right, so notice if I connect my roots, that the shape that I'll make ends up being an equilateral triangle. If I had graphed my roots of 2i, my fourth roots of 2i, well, in this case, I would have ended up with a square instead of an equilateral triangle. And we'll look at that when we, graph our fourth roots of 16. Well, we've already found that above. We know that our roots are going to be plus or minus 2, plus or minus 2i. So if I graph those, I'm going to count each one as, each line as a half. So we'll call this one 2, negative 2. Ooh, that did not work. Still did not work. There we go. Well, maybe not. There's my straight line tool. All right, so again, if I connect my solutions, I end up with a regular, and in this case, my shape is a square. So my roots of my roots of complex numbers are always going to create a regular shape. This does not look so regular here, around the unit circle. Or it doesn't need to be a unit circle, but around a polar coordinate grid.